also wanted to make this a little bit lively and interactive, so laptops down, phones down, maybe quickly finish eating. But I tried to put us all in a very uncomfortable position too, at times, so that I go to them and say, random symptoms, hello, my name is Johanna, que sí, ¿qué tal? Tengo interessant is, maar ik wonder of jullie kan verstaan wat ik zeg. Maybe there's one person who said, yeah, this is South African. So, we're going to do this to each other, and I'm going to guess how many languages I know. Go.
Good. Uh, Thank you for that and for the three brave souls who actually stood up and changed table. Many just turned around, which is equally good. We have about 200 people there, I guess, some languages. If you understood what you heard, raise your hand. Some people did understand. So we have some multilingual people in the house. That's good. If you knew the language that was heard, raise your hand. Okay, so we have some language ID people there. So please come help us label our data so we can see what our language ID classifier is. So I mean, that is the reality of today for the world. There are 7,000 languages spoken in the world. Most of that 7,000 is oral only languages. If you travel the world, you'll find out that it's kind of difficult to communicate with the people in country. I have the opportunity to have traveled a few places in the world. I love mountain biking. I love cooking. I go places. In Thailand, I had a host who took me around, and she could speak English, but nobody else in Thailand could speak English. And we use hand gestures and body language. So I'll share an interesting story there, and it was the highlight of my trip and a memory. Like, so I paid $20, I think, an hour for this person to take me around and basically have me eat all day, the best food in Thailand. And um, the Saturday of the trip, I was going to leave on Sunday morning. The Saturday was her birthday. I was like, okay, go do your birthday. She says, no, I committed to taking you around. And so I was really blessed to be part of her birthday. And um, she invited me at 6 a.m. in the morning. She does a birthday ceremony, a Buddhist ceremony, where she gives thanks and you meet at 6 a.m. And she invited me to come there at 6 a.m. And nobody spoke English at all. The mother kind of said, hi, good. And this lot of body language happened, and that was another way to communicate. But I wish I had um, the Star Trek communicator or the Babelfish thing I put in my ear, and magically I can speak any language. And so I want to build that. I don't think I can put a fish in people's ear. Um, I think we maybe design one, but I don't think a user interface will quite work with fishes in people's ear. But perhaps we can go a little bit more practical. So that's the intro to the talk. And please feel free to interrupt me, or at the end, I guess there's time for questions. Okay. I'll start with Google's mission. So Google's mission stated is organize the world's information and make it universally accessible. This has been the mission of Google from day one. And I think what's really important if we want to be true to our mission is to really look at the semantics of the word. So we're saying we have to organize the world's information, not the first world's information, not English. There's a lot of information on text on the world, but there's a lot of information in countries, in culture. How do you organize that world's information? And to make it universally accessible, like how can people across the whole world learn things, access information, find out where is the nearest pharmacy? How do I navigate there? Who won the World Cup? What was the score? So who did win the World Cup? Okay, so that's the stated mission. If you have access to information in different languages, you learn a lot of cool things. On the flight over here, I watched this very awesome biography, and it was partly in Urdu and I think partly in another language I don't understand. So I'm gonna call out the name, and if people know the name, raise their hand. Sinai Nawal. Um, so she was world #1 badminton player in India, the first female Indian badminton player to reach world #1. It was her biography. Absolutely amazing movie. But I was able to learn that because it had English subtitles. And I was able to enjoy the movie and feel the emotions because I had access to it, even though it was in a different language. And so making information like this universally accessible, I think is just, I find it very uplifting, and it's really an important goal that we take this mission to heart. So we are far from this goal. Like I've been working in the industry for about 30 years. I started around 93, probably gives away my age. Um, there are 7,000 languages in the world. We've been working in speech and language technologies together for many years. The collective knowledge in this room is mind-boggling. How many languages are we able to use our voice to access information with? Google has about 80 languages deployed. Not all of them work equally well, unfortunately. We have far to go. Even the languages we have deployed, we have far to go. Even in the US English, we have far to go. It doesn't work as well for everybody. And so how do we tackle this goal? It's pretty interesting if you look at language. And I mean, language is really like it captures so much information, it carries emotion. Um, and some languages are oral only. How do you organize that world of information? How do you make information accessible to everybody? I mean, languages is also, and many of them is unfortunately will slowly die out as well, just due to the usage. Kind of there's this difference between what we call a contact language and then your oral only language. And due to how it's evolving, a lot of these languages will die. So one question is, what can we do to preserve these languages, perhaps? Here's kind of a plot of data resources that we've been working on at Google. So maybe kind of want to state one of my goals. So the project I'm leading is called the Language Inclusivity Moonshot. A moonshot at Google is kind of just a fancy name. We call for a bold goal that we want to achieve. It's going to be difficult, and we need a lot of collaboration internally as well as externally in order to pull this off. Out of the 7,000 languages, I just set a goal, and actually not me, it's actually Jeff Dean, our in research. Can we build speech and language technologies for 1,000 languages of the world? So not all 7,000, just take the top 1,000. What will that take? The dots you see here is 1,000 dots. Most of them are white, which means we don't have any resources. The goal that I set out is, can we get 1,000 hours for each of the next of 1,000 languages, so 1,000,000 hours of audio? Can we collect such data? What is it? How do you do it? How do you do it responsibly? How do you do it with engaging with communities? If you have such data, how do you use it to build these technologies? I actually do believe it's possible to get to 1,000,000 hours of audio this way, 1,000 by 1,000. I believe the tech industry has the financial resources to help with this and to work with communities. Logistically, though, I don't have the answer. In some pockets of the world, it's easier. In other pockets, it's a lot harder. And so this is why we call it a moonshot. It's a non-trivial problem that we need to solve. But even though we've made so much progress on self-supervised learning, and we say we can build fantastic models with little data, we still need data. We still need labeled data. We still need to understand the linguistics of the language. So we perhaps don't need 100,000 hours anymore, but I think 1,000 will go a long way to build high quality systems. Another thing I just want to emphasize in the moonshot, and this is what I feel is pretty crucial, and this is a very bold endeavor from a research perspective, but we can't stop there. Like, our end result is not a paper we publish on, we built 1,000 languages, we got these results done. We have to be able to bring these technologies to the user so that they can benefit from having access to information. So we want everybody in the world and have you get access to the internet, which is spreading faster, pick up their phone, click a button and speak their language. Like, gee my 'n lekker melktert resep. En hoe kom ek by die naaste restaurant? So those are like, what's the recipe for milk tart, and how do I get to the nearest restaurant? Or how do I get to the pharmacy? Or my child has a fever of 102. What do I do? And there's questions we take for granted. We just type it to our browser and we get an answer and we do something. This is not true for the whole world. And can we make this happen? I spoke with somebody from South Africa today, kind of from but sometimes I tell myself, maybe I'm naive, but maybe I'm just very hopeful. If we can solve this mission, I believe we will lift economies of the world. I believe dictatorships of the world will fall because we brought information to the world. It's not going to be an easy road, but the world will become a better place, and the world will be like Star Trek, where it's kind of one of my favorite kind of TV series. But I think it's possible, and it requires us to break the language barrier. Kind of spoke of. Okay, so I want us to play a little bit game of imagine, and I kind of gave a lot of this already, but and in this room we have, I mean, creative minds who love to solve problems, who love to tackle difficult problems. So like, the limits of what we can do is how limited our imagination is. And so if every person has access into their information in their own language by voice, I mean, as the earlier slide, not everybody, the literacy rates in the world is around 40%. It's rising. But I mean, many languages don't have a writing system. you speak and you want to answer back. So how do you build such systems? So if you had access, what would it be? Um, we experienced a little bit of this game, like, can we communicate with each other regardless of our language barrier? Like, I can speak Afrikaans and English. My wife is from China. I've tried 3 times unsuccessfully to learn Chinese, maybe just not committed enough. Like always somebody says, ni hao. It's like, and they say, oh, you speak Chinese? Like, idian dian. It's like, okay, that's about the extent. I can say wabaola, which is very important because if you meet your parents in China, they feed you a lot of food and you have to say, no, I'm full. But if we can communicate with each other regardless of language barriers, what would that lead to? What would the world be like? So I'm going to play a little bit fun video clip. This is the future. It's the Star Trek Universal Communicator, which is really interesting because I never figured out how they built the user interface part of this. Like everybody can understand each other, apparently in English, but this is when the communicator goes wrong. So there's 1 minute of this. It's kind of funny, but it just... Okay. Internet is currently not
Communicate with it or disable it, and quickly, please.
Cover up, we should both via.
Okay, maybe in interest of productivity, move on.
Goerlach, bek, boemweg, domage.
Pourquoi parlez-vous klingon?
Potato che sto indiando più energia.
Jag kan inte förstå något som helst.
Was ist passiert?
Traduttori, universale, non funziona.
Captain Pike.
Okay. I think I'll leave it there, but it's basically 3 minutes of 90 languages being spoken on deck about, and you can't understand each other. And then the universal communicator starts working again, and then suddenly everybody speaks English again. Not sure how the audio from your mouth gets translated mid-air, and then you only hear English, but that's science fiction. But just shows you, if you can't talk to each other, then you get really confused.
Communicate with it or disable it, and quickly, please.
How do I, okay. Sorry, this is the last Star Trek video, I promise. You can already know that I am a science fiction geek, and the latest Dune movie was absolutely awesome, so if you haven't seen that. But here's another imagination that I've had, and I would like to build this. Part of this, I have inclinations of how to do it, but so I mentioned there are 7,000 languages of the world, and a lot of them will die. So imagine we had the technology to capture a dying language, the linguistics of it, the essence of it. And here's a dying language, Klingon, because they're not really making Star Trek movies anymore, or maybe they will. And in a future generation, you could imagine, so you as an individual say, my parents or grandparents spoke language X, Afrikaans, hopefully it doesn't die out. I don't know what Afrikaans sounds like. It's part of my heritage. I would like to learn it. How do you do that? Maybe there's clips on YouTube for language Afrikaans, probably, of course there is. But not all languages are captured like this. If you go to indigenous languages in Australia or America, or many languages in Africa, which is just absolutely awesome linguistically, these languages are extremely rich and a lot of information and cultural heritage captured in them. What if you could somehow capture it, and now as a youngster in the far future you want to learn it, you bring up an avatar and you converse with it, and it teaches you the language of your heritage. Wouldn't that be cool? I think it's cool. I get goosebumps when I daydream like this. I daydream a lot. I always like to build what I daydream, so I guess it's good. I'm not going to play this one, but this is just a little avatar that teaches you Klingon. You can go to YouTube if you want to learn a few words of Klingon. But imagine you can learn languages this way. Wouldn't that be a nice thing to do from a computer science perspective? And the mathematics and linguistics. Now go away from the daydreaming. Let's start thinking like, how would you build such a thing? And now let your mind like, what would a model have to capture? It would have to probably be multimodal. It probably would have to be able to synthesize video. I imagine in the future, I said it's an avatar, maybe it's like a three-dimensional avatar, not with a headset on your head. I'll go to my holodeck room in my basement and interact with it. But I think these things are, in some sense, possible. Like always surprised what the future brings. So that will be interesting. No, I don't want to play it. No. Okay. But this is.
Nechaurai sada ging ngaboro ga uchi chunga ngabada gara ngaboga uda wi kamina ka aisi kam unwin kai tira a. Nechaurai kada ge sida di ombitnara omuko ngata de. Nechaurai sin mama kada ge sida din aisa ran ngabo ko ngabadu guru muse. Ami kada gara kai uriro bada ge uchi tung naran ngun tung nan anu iru gara ge agin abira ho negada unnachi.
So this is a language from Namibia. And one thing about the languages in Africa, linguistically, with the click sounds, which I won't try to emulate. I can make clicks, but I don't know what they mean. But it's amazing language linguistically. I have no idea what he's saying. I would love to know. I can guess. I think it's something to do about the tree and the nature and properties of this tree. He's perhaps explaining it. That's only a guess. Would be nice if I was able to do that. It would be nice if this gentleman would be able to do the same in different content of the world, not just me consuming it. So I think this is why I think solving languages for the whole world is really important. So we went from imagination, we can dream all day long, what if. It's really important that we actually start building. It's in my experience in kind of my professional career, if you tackle difficult projects, it's just start. And you may not make progress immediately. You may feel stuck at times, but just start. I sometimes write poems, or I try to write a book. I can never actually make progress, but I just try to start, and then sometimes suddenly you wrote something and like, oh wow, where did that come from? I find that with code. I start with a difficult project. I really don't know what to do, but if you just start coding, things will flow. I told you ahead of time that I'll share some stuff about me, but in terms of building, when I was 10, I started coding. My dad brought home a Hewlett-Packard, and for work, and I quickly grabbed it, and it had a basic interpreter on. That's the only language had it. I don't know. The interpretive language. I don't know if BASIC is still alive today. It probably still is. And 10-year-old child me didn't. Perhaps I did do Hello World, but my first program, and I tried to write, and I didn't get more than main print input was baby. I wanted to build an artificial intelligence, and I thought that was possible, but I'm still trying to build things like that today. And so it's important we start building, and even though it will take us time, we'll get stuck. So to build speech and language technologies for the world, we need to be able to understand your language, that's automatic speech recognition. In order to have access universally available across language barriers, you need to be able to translate it. This content needs to be consumable in your language and need to be able to synthesize. I mean, future synthesis will also be multimodal, so it's visual output as well. We need to be able to bring information, so various natural language, semantic language understanding. I mean, this is just to name a set of 4 main topics. There's plenty more, but we need to build these technologies in 1,000 languages. Collectively, I believe we can accomplish this. There's a lot of work. I think it's sometimes just hard to keep up with the rapid progress that's being made across the world. Different labs coming with incredibly good ideas. And so we can build on top of each other's knowledge, and collectively we will solve this problem. So I here just captured 3 papers that I really enjoyed reading about how do we solve at scale, and there's a lot of work towards like self-supervised learning, fully unsupervised learning, like wave-to-vec-u from Facebook is a really interesting approach. So, what I find encouraging about these techniques is people are really starting to look at, well, what does it mean to build 1,000? The resources at 1,000 is varied, sometimes non-existent. What does 0 shot mean? How far can you get away with 1 hour? So a lot of interesting work ahead of us. Some interesting research questions as you tackle languages and you go deeper and deeper into the tail. So one is orthography, and I must admit I actually know very little about this as you go deeper into the tail. So if our experts in the room, please come talk to me and educate me on this. But in the languages we speak, I think we take orthography for granted. There is a writing system. We use it to communicate both professionally and socially. As you go to more languages of the tail, many languages are largely oral, but there is a writing system defined, sometimes by the government. It's not universally adopted. Let's say we build a product in a language and we choose a writing system because now we want our products to have both written modality as well as audio modality. Is that a good thing? Did we just set the standard? And so I think these are questions you have to solve with care. In oral-only languages, what are the products? I don't think we can take the products that we use on our smartphones as this is what the rest of the world needs. I think even though we can type, I actually believe multimodal voice and image as input and output modalities is far easier to consume. So if I want access to information, how do I present it to a user so that they can consume it in the language? It's not, here's a Wikipedia answer, now go read it and click your links and do your research. You really need to be able to consume it in your voice. And so languages that are oral only, I think, provides a very interesting research and algorithmic challenges. How do you build these systems that even do not have orthography to base on? What do you base your model on? Then the last, I mean, this is not the only research question. These are just really some of the top 3 really hard ones. And I'm just going to spend some time here and stress this. in order to solve this problem at scale, to build for 1,000 languages, like we can't do it alone. Like I can't just do it alone. Google can't do it alone. This needs to be a collective goal for us. Like we as a community who have the brains and the ideas and the passion, I hope everybody here shares this passion, should come together to solve this. As you work inside, let's say, a country like Namibia, how do you engage the community? That they feel part of it, how that they can benefit from it. To get understanding the language, to build it, the technologies for the language, it's going to be important that we figure out these solutions. The logistics behind it is really, really difficult, I think. So it's one of the difficult parts of this moonshot. I think it's not only the research and the neural models we build, but logistically it's actually an incredibly hard problem to tackle. So I'm going to next move over to a few areas of research investments that I would encourage. These are not the only, but it's kind of areas that I think have already shown benefit and which I think is important. Okay. So I'm focusing a lot today, and I've mentioned this word a lot about data and how do you move to the tail. I want to collect 1,000 hours for 1,000 languages working across communities. How do we do this? So I'll share a couple of projects that we've been working on. In India, we have a project called Vani that we kicked off kind of towards fall last year, and it's going to be in full swing. And what we're trying to do, and this is what I actually find a really interesting approach, rather than say, we want to collect this language. India is an incredibly diverse country from a language perspective. And Africa is like this as well. People are multilingual from day one. So in India, rather than say, we want to collect Telugu, we want to collect Gujarati, we're saying, we want to go into district, there are 773 districts, and we want to collect the languages you speak. So, and we don't tell you, please speak X. So the hope with Project Vani is to get the true linguistic diversity of languages in India captured, and then from that to start tackling the modeling problem for all of India. So this will capture all major languages spoken in India, but also all dialects. A related project, and actually this is called Project Wahal, and it's based in Africa. And it's actually, the ideas of Wahal was used to seed the ideas in Project Vani. It started by, it's ex-Googler now, amazing gentleman, Mustafa Sissi, who's a computer scientist in Africa. And with Wahal, we're collecting audio through WhatsApp by sending image prompts to users. The pilot of Wahal was done in Wolof, as a language spoken in Senegal, where participants of the community get an image and they speak for 15, 20 seconds of describing the image. And we have approximately 500 hours of Wolof collected, around 10 to 20 transcribed. Transcription is a harder problem, but what's interesting about this approach, the images are kind of culturally relevant, and it's what you see in your everyday life. And so it's aimed to elicit a interesting and good and varied response. And Project Vani is doing something similar in India, and in the rest of Southeast Asia, we want to do this same. And I also want to emphasize, in all these projects that we are seeding, the aim is to open source this data. The way the projects are actually aimed is we help design it, and we work with a university partner whom then may work with a vendor. Google actually doesn't own the data of this. The first time we get access to the data is when we can download it from GitHub. Just like the rest of you can download it. So the data flows kind of university partner, vendor who's involved in many cases, to GitHub, and then we can download it and work with it, as well as we encourage the community to do the same. I spoke to a whole. Similar is a project called Crowdsource, where we get community participants who are excited about their language, Instagram influencers, who bring community together and say, hey, go to this website, donate your voice. In each of these methods that I've discussed are all in their seed stage. I think Vani is the one that's scaling pretty well in India. But they're each aimed at basically trying to find ways to tackle this problem. And one methodology that I work a lot on is I don't like to take only one bet, because I could be wrong. Also, when you take many, so I tend to take many bets. You also learn from each other. Each team that gets excited about it brings a different perspective, and these can influence each other, and we can learn from each other. So the project Crowdsource is just kind of bet number 3 that I described in this. Okay. If I zoom into American English, and as I mentioned, our technology works well in English. I mean, we've been looking at that forever, and we've got a lot of data resources. But if you go to users in America and you look at African American vernacular, you know what? It doesn't work. For a lot of people, it's like, I tried it, it just doesn't work. Sorry. I've met people on the train. It's like, hey, what do you do? It's like, and what I do a lot sometimes is like, oh, do you speak to your Google Home, or do you say, hey, G, to your phone? And somebody says, oh, yes, I love it. But many times people says, and then after they say, hey, yes, I love it, then I say, oh, I worked on it. But sometimes they say, yeah, I tried it, it doesn't work. And then I don't say I did it. I should. So. But even in languages that we say, well, we have the resources, you know, our technology does not work as well for everybody. And so that's, if we want to be true to our mission, we need to start tackling these problems. Okay. So second area of investment I called, the general topic is multimodal modeling. So this is an area which actually, wow, got 5 minutes left when I was told it's like it can only be 45 minutes. Like, wow, that's a lot. Is audio and text as 2 modalities. So there's a lot of audio like on the web, not labeled, but YouTube, podcasts, other platforms, TikTok. There's a lot of audio on the web for different availability. There's a lot of text on the web, billions, or I guess trillions of words, nothing to do with each other. And there is some paired audio that we have, like, for example, you can use LibreSpeech or other multilingual corpora. Each industry may have their own specific to the product corpora, but typically I should have drawn that box a lot smaller. It should be a tiny line, actually. How can you use these large sources that are nothing to do with each other but carry a lot of information productively? So this area is actually exploded in the last few years. There are a lot of research papers in this field, and there's still a lot to be done. I think there's a lot if we can join the knowledge in these 3 corpora productively to solving our problem on a larger scale, and to be able to tackle, I wouldn't say all 1,000 languages, but I think we can get to good quality in 500 languages using corpora like these. not all knowledge is locked in audio. There's part of me which I actually think we're taking perhaps too much of an engineering approach to solving speech and language when we have labeled data. As a child, I didn't learn to speak by my mom giving me labeled data of audio and text, and then I learned to understand her and read at the same time. I learned from hearing her voice and hearing my brothers fight and seeing the world and touching things and biting things. But those are multiple modalities, where image modality is a huge component of that. I learned language, and then I learned to label it when I learned to read. We don't build speech recognizers like this. There's one very cool paper from David Hardwith, a university professor at UT Austin, that's tackling it, that I'm super excited about. So that's an area that I think we need to look at. I have this hypothetical question which comes back into my imagination, but if we look at the oral-only languages, how do we capture them? I can't label them. Perhaps I could translate some of them if I can find a speaker who can speak a written language and they can translate it for me. How much of it can I capture if I'm able to have the image modality in it? I think it's a really hard problem. I'm not totally sure how doable it is, but I think the image component is lost is the wrong word, missing in our speech language research. There's a lot of image text research that's focused at a different problem. There's text to image generation focused on a different problem. But using image and video as a way to learn and capture language corresponding with the audio, I think is important as well. And so that's the end of my talk, and emphasize our mission. And this is Google's stated mission, but I think should be our collective mission. Like, we need to work at the world's information, where world is important and universally accessible, not only accessible for the languages that we speak. We are very blessed individuals to be able to travel to conferences to learn things. The rest of the world can benefit from our energy in this space, and so I want to encourage everybody, put your energy in this space, bring your passion to it. And when I said energy, I went goosebumps. It's like, I really, put your heart and soul in it. I think you will make an impact to the world. Thank you.
Thank you, Johan. We have time for a couple of questions. Please come forward. Our AV crew says it'll be ideal if you come up here and speak. That way, for the recordings and for the remote audience, we'll get a good shot of the question asker as well. So who wants to take the first one? Anyone? Okay, while people are thinking, Johan, maybe I'll ask you a quick one. This has to do with languages that are not written. I'm thinking about translation into that language. And I'm at a loss as to what might work. So suppose I wanted to have the English Wikipedia available to somebody who speaks that language. What's our first step?
So that area we call speech-to-speech translation at Google. So where input is audio and output is audio, and you may or may not want intermediate text. And in languages that are oral only, you can't have intermediate text. Right. One specific technique that I'm pretty excited about, and it's a paper published recently at Google, and there's some new work from Microsoft, they call it the audio language model, is to use language modeling techniques, but based on audio tokens. And if you could combine that with the knowledge that are in text, even though it's nothing to do with the language, text models capture semantics across multilingual. So I'd say step one is you need a multilingual model because you need to learn from each other and you need to transfer learning. And then techniques like audio language model, it gives a path. I wouldn't say a guaranteed path because I haven't seen too many results yet, but it gives a path to modeling that language.
So, okay, so somehow turn the language model, the audio language model around into a generative model, if
That's
you will.
correct.
Okay, all right. Okay. Other questions?
Don't be shy.
Go ahead. Fred, come on up. Just step up over there. Right there. There's a cross on the ground. Come up forward. Yeah. All right. So it's like the...
Okay, is this good?
Yes.
Okay. I think sometime last year I read an article in which Meta had developed a speech-to-speech translation from Taiwanese, which some people might call Taiwanese Hokkien, to English. Mm-hmm. And one of the things that makes me wonder is how far are we from somebody being able to do a Google search with just their voice? For example, as Sanjeev had mentioned, from an unwritten language.
Yeah, I can't tell you the answer in terms of months, but I don't think that concept is too far away because, and this is one of the projects that's been working at Google, and there's actually related work, but if you're working with an oral-only language technique, you can do kind of audio to rank. Like you don't have to rank text, you could rank embeddings. And techniques that organize the audio or the video in embedding space can start enabling this. So I think all of these are slowly becoming possible with modern techniques. Yes.
Okay. Do we want to do one more? Yeah, come on up.
I just wanted to hear your thoughts on what different ways can technology assist the documentation and preservation of languages. So I think one kind of clear way that this can happen is just transcription of audio as well as linguistic annotation of those transcriptions. But you mentioned there's also a need for kind of creating these tools for people to even learn those languages in the future. And then I've heard other people say that really the most important thing for preserving these languages is just getting grandparents to talk to their grandchildren in these communities where the languages are dying. I just wanted to hear if you, just kind of what different ways you see technology helping in this process.
Yeah, so the one thing that I think happens in this communities is storytelling. It's actually very common. And can you capture these stories and preserve them? You mentioned like grandparents telling their stories to their children. So that is true, but unfortunately I see this also withering effect that these grandkids, when they become grandchildren, may not do it to the same level as their own grandparents. And so over time, one reason the language dies out, also the children, in order to function in the world, start using what this is a term that I got from Professor Stephen Bird, who gave a talk on this, called contact languages. So they don't use their language that grandpa tells a story in, they use a language that they need to function in society with in order to have an economic kind of survive through the and grow. But if you can capture these stories and not only preserve them in audio form like a museum, but preserve them in an interactive form, I feel this is why I have this imagination of an avatar, that you now have the opportunity to really preserve it, where it's more than a history museum.
Thank you. Johan's going to be here the rest of today and tomorrow, so more questions are always welcome. And as he said, he wants your ideas as well. So let's thank him now, and you can catch up with him later as well. Thank you, Johan. And we will move right on to the next part of our agenda today, which is a panel discussion. We'll need just a minute to reorganize the stage a little bit so that we can have our panelists sit around and talk. So everybody stay here, don't go anywhere. We'll roll right into the panel discussion. So the panelists, Roberto, Bjorn, All right, so let's get going. This panel has a question or a theme that was intentionally chosen to be, I wouldn't say controversial, intentionally chosen to be somewhat open-ended and I wouldn't call it worrisome, but thought-provoking. And the question is, what comes after deep learning? So built into it, there's this assumption that there is something after deep learning, that this is not the end of the world as we know it. And in posing this, we had 3 or 4 questions in mind. And rather than hear from people who have been, first of all, the hope was to find people who have been in the field for a fairly long time, who have seen many changes go through, and sort of reflect on what's happening and what has been happening for the last 10, 15 years or even longer. And the other idea we had was that I wanted to get opinions from a lot of different people. So while I'll introduce our 5 panelists in a minute, we also spoke with a number of other colleagues via Zoom and talked to them and collected their thoughts and created short videos with quotes from them. So the way I'm hoping we'll do this panel is, I will put forth a question or a prompt. We'll hear from the people we have already spoken with earlier, what they have to think about, what they have to say about it. And then we'll go about and our panelists here will reflect further on it, add to it, disagree with it, debate among each other, whatever we like. And while we have 4 questions in mind, I don't worry if we run over and don't finish all 4. We just want to have a good discussion. If we do 3, that's perfect. That's my plan. If we only do 2 and you have a lot of other questions, that's fine too. Because this is not a debate or discussion that's going to end today. It's going to go on for many more years. So think of this as just the beginning. So with that in mind, I'll quickly go around and introduce our panelists. They're all well-known people, so you really don't need a long introduction. To begin, Bhuvana, she is the general chair of this conference. And she has been at IBM since at least '95 and has done many good things in speech and language. Next to her is Björn Hofmeier. Björn is back with Amazon. I think of him as one of the fathers of Alexa. He went there while Alexa was still a stealth product and has done a lot of good science and engineering behind it. After that is Johan. I won't introduce him again. You just heard from him. Then there's Roberto Pericini. Roberto, I think also started in the mid-90s or maybe even early 90s. Bell Labs, SpeechWorks, Speech Cycle, director of the International Computer Science Institute at Dixie, Jibo, and now Google again. And I remember him most for his work on spoken dialogue, introducing ideas like POM-DPs and trying to quantify how dialogues flow. And last but not the least, Professor Alex Weibel. Alex is a professor on 2 continents. And for some of the younger kids around here, if you want to see the first papers in neural networks and speech recognition, you have to go back to '87 and '89, when Alex and colleagues at ATR and Kevin Lang was involved, and Jeff Hinton was still at CMU, or at least was visiting at the time. And the first paper I like to think about is Alex's paper on time-delay neural networks, whose fancy new name is CNNs, but it's the same thing. So this is a panel here, and the people who we talked to and interviewed earlier, you'll see their names when you see the video. So Desh, I'm ready to cue the first video. Just go ahead. So the sort of, the premise or the first setup of this panel is that, in the last 10 plus years, I would say, we have seen a massive explosion of neural network applications to speech and language technologies. And many, many things which we thought were very hard problems have sort of fallen to these approaches. So when one thinks about it, one can ask, do we really need any other techniques anymore, or is this the hammer that's going to nail all nails and we're done with this? So that was my first question, and if and when we get the video going, you'll see that, and then we'll see some answers to those. You all said they should not yet. The video is not working, all right. All right, give us few seconds. And in the meantime, do you guys want to just say something in response to that question already? So let's start. Who wants to start? Are we done with techniques for speech and language? Is everything we need simply neural nets, semi-supervised learning, a little bit of labeled data, throw an encoder, decoder at it, maybe transformers, and we're done?
Okay, I have the honor to give the first answer. Well, what I think is I guess I look at it a bit differently. All right. I think what is happening, or what has happened in the speech field, is that from solving an ASR problem and looking at machine learning solutions that helping us with that, we kind of transitioned to doing machine learning and applying that to ASR, to speech recognition in my field. And when looking at that from that perspective, so right now it is deep learning that is governing machine learning. But now that we are doing machine learning, with the changes in machine learning, we will apply it to ASR. So whatever comes next in machine learning, I'm not sure what it is, but I'm pretty sure we will apply it to ASR.
Well, it's an interesting question because obviously my whole career I worked on neural networks, and it began at a time in the 80s and 70s when people tried to solve the problem with rule-based methods, right? So people wrote rules to do four-man trackers and things like that. And I was looking at the famous people at the time and saying, this is like emperor's new clothes. How can they possibly think you can solve the speech problem by writing rules? And inspiration comes from looking at how human beings do it, and human beings clearly do this by learning. And so we began on this long road and journey on doing machine learning as a solution for the speech problem. So to ask me now, are we there? And is neural networks there when we strived all of my career to do it with neural networks? In some sense, it's satisfying that it was, but even there along the way, people would say, oh, but isn't it just like a fancy k-nearest neighbor? Or couldn't we do this by statistics? So there were lots of other avenues to doing it. And my answer was always, the most amazing thing is not necessarily the performance, but the fact that these neural networks derive hidden structure without you telling it, right? It learned something in between. That was clear to us in the 80s. And we had lots of debates and people disagreed, but now we see this is exactly the case. We can do unsupervised, we can do all these things, and it's because we learn hidden knowledge without actually without telling it to do that. So now, if you ask me what's next, I don't think we'll give up on this because it's performance-wise simply better. However, I think we will now, or at least I complain about the lack of structure, right? So you now have this big blob of something that works wonderfully, but it's totally unstructured. So if I give you an instruction and say, no, you don't do it this way, you do it that way, you can't use it because it doesn't translate into this big blob of distributed knowledge, right? So I think what we'll do in the coming years is, in fact, move to more structured learning without giving up the distributional power of neural networks.
Yes. Someone else wants to talk? No, yeah. So yeah, it's funny because I'm sitting next to Alex, and then you made me think about 1982, 1983, my first visit to the U.S. when I was living in Italy at the time. And my English was even worse than now, if that's possible. But and I came to your office. You're a student at Carnegie Mellon, and you explained me how the time delay neural network work, and I believed in it. And then I don't know what happened. Then we had to wait how many years before neural network? Exactly. So I think that I don't believe you are at the end of the road. I think we ain't seen anything yet, in my opinion. There are so many things, and problems are not solved. You see, from Johan, we're still, if you want to go to 7,000, you're still like 6,980 or whatever languages to go, and there are a lot of problems here. We are not talking to machines the way we talk to humans. But I would like to talk about two things that we need to think about. One is what the philosopher Dan Dennett calls an inversion. So we started making intelligent design. I know it's a bad word, but we intelligently design our machines. We made modules, we made feature extraction, we made time warping, dynamic time warping, or hidden Markov model and so on. There are a lot of modules. And now we have rules before that. And now we end up something that is not, we don't design, right? It's a competence without comprehension, right? We don't understand how it works, but it was like Dennett says, like the evolution, right? There's nothing, there's no understanding how it works, but it works. It works so well that we are a product of that, and our machine will continue to grow and work well. So I believe we are at the beginning. I don't believe we are at the end. We're just starting to see, we'll see more and more of that. Yeah.
Okay, what emphasize here my view is we perhaps taking an engineering approach to the problem. Yes, we build neural networks inspired by learning because humans learn and the brain, but at the end of the day, we're treating it like an engineering problem. We're making it bigger, we're throwing more data at it, doing well, incredibly well, some of the progress, but we didn't learn language this way. It's like the point I want to make about multimodality. I didn't need 1 million hours to learn English. I'm probably exposed to a lot of information. I'm not sure how much, but less than what we use. And so how we learn, in some sense, much more, they're quicker from the information.
Yeah, but I think that's exactly why we need to reflect back on how beautiful and how wonderful it is that humans do this, because we do it with way less data. And, I just joked yesterday with Sanjeev before coming here, was because he invited me on the panel. I wasn't sure whether I could come, so I sent him a message. Is this on? Am I still invited? Should I come? So he sent me, he calls from India from some phone from a street with lots of noise in the background. And he said, I wrote it down. Yeah, well, he said, that would be great if you could come. Some noise from the street. Again, Wednesday noon, Doha time is the panel. And the speech recognition on my iPhone said, that would be great if you can comfortable again. Wednesday noon, don't have time in panel. So Doha time was transferred into don't have time in the panel. And I'll give you another example. We had a presentation of the European Parliament. We're doing speech translation for the European Parliament, and so the whole conference was automatically transcribed by our system. And it comes to the point where some, I think, Italian speaker, sorry to say, who says, European elections campaigns. So it should be election campaigns, so the S was, but it's a small mistake. And the system said, European election scum pains. So, of course, everyone in the audience was kind of aghast that the system would kind of come up with such a rude thing. But the point is, the system just absolutely doesn't care what you say or doesn't make any sense of it, and that in this context you don't talk about scum, or that Sanjeev's intent was not to uninvite me in such a manner, right, is something that's obvious to us as humans, but we just don't, the systems don't do that at all. So they lack context. They lack an understanding. They lack structure. We can't incrementally learn, right? We can't give it a new instruction and saying, oh, from now on, please talk. We're talking about Doha. Forget this, right? Then the system should change its behavior, right? We're doing some experiments with new languages. You want to add a language, not retrain all of the 1,001st language, right? And this is possible in the human brain, right? And we're not able to do it with the current technology.
So I guess what we're all saying is there's some work happening on interpretability and what are these models learning? And I don't mean it as this layer is learning phonemes and this layer is learning linguistic information, but more along the lines of what is it the model is implicitly capturing overall? And I think we're going to see a lot of work where that's actually translated into a mathematical objective. Maybe go back to the days of speech production, perception, and add it as an additional way to train models so that we can bring back more of the HMM stuff into the actual neural network training. Or at least that's where I think we're all going.
Cool. Okay. Let's share a few more opinions. Desh tells me we're ready to go now. So let's give it a spin, Desh, see if it works. You can skip this bit. So this is the question as I posed it. It simply said, how do you view these advances? Is this the end of the road for new methods? Is knowing how to train and deploy large neural models with a mixture of self-supervised and pre-trained and task-dependent supervised training all that we need?
So I think it was 2006 when the deep nets, Microsoft got that good switchboard result and got everybody's attention. And since that time, so much has happened. The pace is just, it's an extraordinary sequence of, developments, I think. It's all come together. It was amazing to see people jump modalities with these vector representations. So I first saw the image captioning stuff. I think that's right. And to me, that was a real aha moment because, I'd always known the...
Thanks for the audio.
We've connected the aux cables.
Trust me, folks, this was working before, just 5 minutes before.
Yeah, this is technology, guys. Go ahead and play it. Go ahead, yeah. Skip this, go forward a bit.
Golden era for our field. I mean, really, so I think it was 2006 when the deep nets, Microsoft got that good switchboard result and got everybody's attention. And since that time, so much has happened. The pace is just, it's an extraordinary sequence of, developments, I think. It's all come together. It was amazing to see people jump modalities with these vector representations. So I first saw the image captioning stuff. I think that started coming up. And to me, that was a real aha moment because, I'd always known there's semantics in the different modalities and never knew how to cross over without it seeming to be incredibly complex. Now, we can go amongst all these different modalities much easier, and that's opened up a lot of interesting research.
So I think it's really rich. I mean, this is a very exciting time, I think, to be a PhD student because there's so many things that there's so much more that's going on that's interdisciplinary now.
One is about pre-training and supervised training, and I feel that this is getting a lot of momentum, and I also believe that it really helps the fundamentals. And I take human learning process as an example. We as a child, we learn, we listen to people talk without knowing what they're talking about, and we learn and we develop the ability to listen. And although we don't quite understand, but that's kind of the training, right? There's no supervision signals, and we gather how to figure out things, and so this can be done in pre-training. And I always think that the whole pipeline of speech processing
variety of different things, but they still can't do the things that we initially thought should be done, like talking like a real person, and also being able to convey different kinds of emotion in speech. It's very strange, but the things that they're doing now, they'll have topics, and they'll say, this is a voice that's friendly, or this is a voice that's X, but they don't have different emotions that they can generate.
Is knowing how to train and deploy large neural networks using a mixture of self-supervised pre-training, task-dependent supervised training, all one needs to know in the future. Clearly, those are very useful things to do things at the moment, especially for tasks where there isn't very much task-specific data. We've worked on doing things like distilling the outputs of some of those models so that you can actually train them and deploy them in smaller contexts. Mm-hmm. And been working on some things like using, I don't know, WaveLM, Wave2Vec2, things like that, and looking at different layers and using them for different tasks and having, combined, rather than having one model for each, having combined things and using them for, trying to use them in emotion estimation, automatic emotion recognition tasks. And that's sort of interesting, those sorts of things are quite interesting because the supervised data is very limited and the labels, the annotation is often rather ambiguous, that we've not necessarily solved, it's not necessarily changed the field dramatically. We might have, in some places, be able to increase performance pretty significantly, but it doesn't mean that all the problems have gone away. They're still there, and perhaps we've got some new powerful tools which are very flexible, and I guess we get to learn how to play with them and how to use them in an interesting way.
So new tools, but same problems.
So I think there's a whole host of things that can be done now with the speech technologies that are still immature in certain areas or not mature enough in some, but have opened up opportunities that we couldn't do 10 years ago or 20 years ago. And so I think that's really kind of exciting. It's fun to have seen that. Yeah, I'm very impressed by a lot of the results you get with some systems, but they also, when they break hard. And so if you confront the systems with things that they've never seen before, different styles of speech. So I'm using the global week, so it wasn't me that did the test, but recently some people did some tests with either Whisper or some other models that are out there, but I think it was probably Whisper. And while it did really well on like broadcast type data or some YouTube type data, when there's other types of data that was in-house data that they had, like interviews or even conversational telephone speech, sometimes it would fall apart completely. And also the model sizes are huge. So they're completely out of the realm. If you have a linguistic lab that wants to do something using some modern technology, they don't have the GPU, they don't have the machines, they don't have, it's not as saving everything for them. And in addition, can you even get out of it the type of information you want, which I don't know.
And it is working very, very well. Yeah. Mm-hmm. But at the same time, I feel what is, at least personally, because I do a lot of work with Mriganka of MIT, and where we look at brain signals and things like that, we're really not focusing on that aspect of, it's not anymore, not really brain-inspired computing. And I'm one of those who still believes that perhaps the brain is doing a lot of signal processing before it decides to do, I mean, it's not that it doesn't do machine learning, but it decides there are events, these events are detected, and then of course, it does actually very high resolution machine learning perhaps. And I believe that it's actually totally non-uniform sampling. Whereas,
Paying attention to some things in time completely.
Yeah. I mean, I always give this example in the class that when you watch a cricket match, if you're looking at maiden over, it will just pass by. But if there is a cotton ball, you will give exact detail of where you saw the cotton ball. You say deep third man, this person was standing, so many feet from the boundary, and all that you will be able to say. So I am one of those who really believes there's something that wakes up the brain, and I feel it has to be some differential signal. And whatever we see, for example, any transition somehow is what we perceive. And I feel in deep learning, we are missing this aspect of it.
I'll give my view maybe in 2-3 minutes. Only thing is some of them may be highly controversial and contradictory and so on, but I think you should bear with that.
Absolutely.
And, so the whole question here is, I think things have changed a lot in the last 10 years. And some people would say that it is for the good, and some people would say it is okay, some people say it is bad. Okay? And I am speaking mainly from an academic perspective. It also gave me an opportunity, thanks to again Corona and so on, COVID, 3 years time to think. So with this background, what I say, I think things have changed drastically and everybody thinking is technology driven rather than our driving the technology. I review typically about 10, 15 papers per year and at least 4 or 5, half a dozen of them are journals. And what I noticed from this in the last 5, 6 years especially, is that all of them come to me, some of them come to me because I am in the speech area and also the title of that article is speech. But in the whole 10, 15 pages, there is nothing about speech. That is the tragedy of this. And suddenly at the end, they got a better performance and so on. I'm not saying casually, I am a little worried about that trend. I do ask the reviewer author to tell me what aspect of speech help you to improve your speech recognition or your emotion recognition or speaker recognition for that matter. There's no word about it. Simply the fact is my number is better than the number. To come back to the point, I think since we are talking about speech, I think there is very little of speech in terms of speech recognition, speech understanding, or speaker verification, or dialogue, and so on, has to do with the things that are going on now. Okay? But having said that, the performance are improving for the database that we create. See? So the success is unfortunately a rare paint which masks all ugliness. That's exactly what's happening right now.
So success is a rare paint that masks all ugliness. Do you guys agree? Yagna says success is a rare paint that masks all ugliness. That's how he characterizes today's progress. I think you're smiling. Is that too contrarian? Anyone in the audience agrees? So use the cross behind you. Yeah. The stand over there. There's a cross on the ground. Yeah, that's the thing.
I was sitting on the cross.
There you go. Thank you.
So that basically means there is no structure.
Yeah. Yeah. No, so these were some of my academic colleagues. The common themes I heard were things like explainability. Abir said these systems work well, but when something doesn't work, we don't know what to do.
I mean, in our lab, we reached, remember Switchboard, the old conversational database? I was there when it was invented and given to all of us at DARPA, from DARPA in 1993. And at Carnegie Mellon, we worked on the first systems with an error rate or accuracy, I don't recall, of 50%, which meant every second word was wrong. And now we're superhuman performance. We can show that it's actually working better from acoustic recognition than what humans can do. So by that standard, we should be done, right? We're finished. And we all agree here in the room that we're not done. And the question is, what is it that we're not done about, right? And to me, it's this inflexibility of the systems, right? You do this on Switchboard and you get perfect results, but as soon as Sanjeev talks from a street in India, you get this gobbledygook, which doesn't make sense, right? So it's back to a fundamental AI problem, right? How do you make intelligent systems that can deal with change and adapt to new situations as opposed to just do pattern matching? We still do pattern matching.
I just follow up on that success comment. I think also the perceived success, like, wow, this system works well, I get a word error rate of 5%. We get trapped in our own methods and we become incremental and, oh, let's do more of this. I just want to God that you get trapped. The other kind of, and I've fallen into this trap myself, so I plead guilty there, but can we please stop saying that we reach superhuman performance? We have not. Yes, maybe on Switchboard, it means nothing. So collectively, let's not say we've reached superhuman performance.
I agree. So I think I started working in speech, but I've been working for a long time in natural language understanding and dialogue, so that's still my passion. And I think speech is not the end of it. Of course, we can use speech for transcription, subtitles, and so on, but the final thing is understanding the message and communicating and conversing. We are totally not there, right? So there is not a conversational machine that actually works in the same way as we do. Now we start seeing ChatGPT and Lambda or in Google that they're kind of mind-boggling, but we are still far from there. And then when you put speech there, it's even worse. So, and one of the things that give us a sense that natural language understanding is totally not there, and speech is way more ahead than natural language understanding, that you can buy a speech recognizer, and maybe it doesn't work extremely well on your domain, but you can tune it and you can make it work. You cannot buy a natural language understanding system. You need to build it for every different domain. So are we going to have a universal natural language understanding system? And there are people who are working towards that, but it's still very, very far from there.
Yeah, I think it's a good point about understanding. When I look at Alexa and utterances, what is it, 2.5 seconds? Those are what are we processing there? 5,000 features, something like that. Now, we had this nice example about Doha and don't. So if you listen to this audio in isolation and you don't know what it's about, I don't know what a transcriber, what we would do. Perhaps I would hear don't. No idea about that something is happening in Doha. So that's, I think, the point where the context comes into play. So it's about understanding. It's not about the phonetic description. It's not about this 5,000 features from one utterance. It's about, and now we have probably a lot more than 5,000 features representing the context that the system needs to know to understand, to, whatever understanding means, to produce the correct transcription there. And I think that is also where, coming back to deep learning and not handcrafting those features, but having systems that can learn them. And to me, it looks like the distributed representation, I think that's at the core of, deep learning, one of the cores. So that is something that is probably there to stay. It seems to be extremely powerful. Learning those representations, I think we're not doing a really good job, needing 1 million hours of English to learn to understand English. I forgot, I think a human until age, a teenager or so, is exposed to, what is it, 20,000 hours? Something in that, well, it's a lot less than 1 million hours. So we are extremely inefficient. We're very inefficient in adapting quickly to distribution shifts. The human needs one example, and we're there. So I think the learning is a big question there. There's other interesting questions that come up even with the distributed representation. Is it a dense representation or is it more a sparse representation that is more useful? We're coming back to the question of structure. But yeah, I think, and we had this nice presentation here about representation learning. And I think that is what, to me, the future comes a lot down to, the representation of the speech so that we can quickly adapt, quickly change, the representation of context as well.
So this meeting is recorded. We can all agree this is limited vocabulary speech recognition. We should run this against all the best systems we have today, including the Superb Challenge leaderboard, and I'm betting we'll get 110% word error rate. If we get anything near 50, we can declare we've made some progress. Not superhuman, some progress. We can all take bets on this.
I agree with you, but the other thing that's remarkable about humans is they know what they don't know, right? I mean, in this example, with Sanjeev speaking, I don't think, even if you cut the context away, I don't think I would have made that mistake. Because I knew there was a cargo driving by and there was masking part of the information. And even... Yeah, so you know when you can't possibly know, and we have error recovery mechanisms. So at our lab, we're working on how do you recover from errors. I mean, humans are amazingly good at this, at seeking additional information purposely to get the information you want to have, right?
Like we won't hallucinate the words when the word, we'll say, I didn't hear you, can you please speak it again?
Exactly. I would like to be the Davis advocate in talking in favor of the machines and not humans. I know we humans are great to do things the machines don't do, but if you look at the recent, and I'm really mind-boggling recent success of large language models that you can chat with. And, in Google, we have been working on that for a couple of years. And it's amazing. These models only predict the next word, right? So there is so much power in that. I can have a conversation with some, and how do you know that what I'm talking now? I'm just predicting the next thing to say. There is no way for you to know. And so there is no way to know that a machine is intelligent or not. They just predict the next word and give us the illusion of having a conversation more or less intelligent. So I think this is amazing, and I'm really looking forward to see what is next there, but it's really amazing. Yeah.
Maybe we're also just predicting the next
That's what I'm saying, right? So, and I believe that. I believe in Kahneman's system 1, system 2, right? So the intuitive system, the rational system of our brain. And I think when we speak fast, like I'm doing now, my brain doesn't now have time to plan what they're going to say. So I really rely on my ability to predict what they're going to say next. I think it's not far from reality. Then if you ask me, what did you say? I start thinking, oh, shoot, what did I say? Right? But I start doing rational analysis of the intents and things, but I don't think there are intents in my mind. I have some goal, vague goal, and I'm just putting words there.
So one is, in one of the things, I have a feeling that we may not be able to go through all the video recordings I have from the meetings, but Carol S.P. Wilson said something along the same lines, that these machines often make mistakes that a human would never make. And then the other thing, Johan, in answer to your question, Phil Woodland had a very nice comment, which I'll repeat. He said that one of the things we are suffering from in the last few years in particular is that now we have so much more compute and so much more abilities that we're iterating on these test sets. And sometimes, a lot of the times when you get incrementally keep reducing the error rate down to 3, 2, 1%, we're actually fooling ourselves, because on that test set, we are reducing error rate. And it's great to publish a paper or to have a press release saying, I don't know, Chinese to English translation has reached human ability. But you ask yourself, how many times did you evaluate on that test set? How many experiments did you do? And if this were a FDA drug study, I'd get thrown out for p-hacking because I keep doing experiments until I get it right. So in some sense, and I don't mean this as a critique of the people who are doing the experiments. I think we have not recognized that our paradigm has changed. And Phil Woodland said something like, 15 years ago, we couldn't run so many experiments on the same test set. And also DARPA and IARPA, and they would come up with new test sets every year, which was a little bit different and a little bit harder than the previous one. And that kept exposing us new things. So for all of us researchers, one of the lessons I think we should take home is that, we shouldn't just keep working on the same trained test partition for too long, because at some point, the utility of what we're learning starts to reduce.
Yeah, so 1.5% on dev other than Library speech, is that better than 1.6? It's like, sorry, it's noise.
Yes.
Yeah.
All right. Plus it's overshadowed by your application. Your interface is not good. So let me maybe get a few audience questions, and there is another question that I want to go to about techniques and what things new researchers should learn. But has this inspired anyone to come up and make a comment or ask a question? Yeah,
well, I think, I forget who said it, the word illusion. I think that's probably what bugs me currently the most, is we're getting so good at predicting backward looking, right? I mean, the knowledge is all trained on past data. It's not the future data. And we're getting so good at the illusion of understanding that it bugs me, because we know it's not the case. I mean, we did experiments with automatic back channelers, right, where you know exactly when to say, You can train a system to do that. And it knows nothing about what you told it to, but it seems really human-like, right? And with ChatGPT and similar things, you have that too. You type this in, and first you say, whoa, this is intelligent, right? It's not, right? So we really need to worry about the problem, what is intelligence and how we contribute to that problem to create better agents, in my opinion.
Audience questions or comments? Jimmy, anything? Anyone? Oh yeah, Fadi, come on up. There's a X on the spot over there, and if you stand there, the remote audience will see you smiling.
Thank you for the discussion. It's awesome. The way, I totally agree with all of what you said in terms of intelligence. We're not really learning intelligent systems. We're not teaching systems to be intelligent at all. We make mistakes that humans will never make. And the problem is that I feel that we are using techniques that actually move us towards to not intelligent systems. For example, suppose I'm just going to give you, imagine this crazy experiment. You take a baby and give this baby audiobooks. That's it. That's the only thing you expose the baby for 18 years. Will this baby be intelligent ever? And this is Hubert, wave to Vic analogy. If you give them transcript, now this is our ASR system, so they will never be intelligent this way. So that's my problem, that we are if you look at the papers here, the vast majority of the papers, the first thing they do, Hubert or wave to Vic. And what do you think about that? How do we push the community to actually move away from this direction, from this way of thinking, that intelligence is far more than just listening to audiobooks and interacting with the world and other sensors and so on and so forth. Thank you.
Yeah, I'll just respond. I think I actually don't like the word AI, like artificial intelligence. I like machine learning. We're using machine to learn things. We're building classifiers. And I think for the domains we're working on and the products we want to build, I also call it an engineering approach. There's nothing wrong with that, and it works amazingly well. It's not AI. We talk about AI and we impress people, but I'm an engineer. I'm building an engineering solution, and it works well.
Yeah, but there is but I think what you mentioned, that is something that excites me about Alexa and working on Alexa, because we do have an interactive system. We have a system that really interacts with the user, and we get feedback there. And it's a large-scale system. It is somewhat natural interactions. So we should be able to do kind of exciting stuff there. And so you mentioned it. So humans know when they don't know, and they ask for clarification in smart, pointed ways. So can we do that with our speech recognition systems, with an assistant system? I think that is a very challenging, interesting task. Can we learn from those signals distribution shifts? So I think that is a direction I would love to go, taking really advantage of having here an interactive system.
And there's nothing wrong with it. There's nothing wrong with the system to be limited, right, in its knowledge. It can say, I don't know, right? And as long as he knows what it doesn't know. I think what's really dangerous is giving this an illusion of intelligence to make people believe it knows something that it doesn't know. So there's absolutely nothing wrong. In fact, I like the approach of the engineering approach. Let's build a tool, but then the tool needs to communicate better what its limitations and what it's designed to do, right? As opposed to pretending to be whatever the next generation in human evolution or something, or whatever other people say.
I would even claim it's pretty human that we don't understand, and we very naturally ask clarification questions. So such an interaction mode would, I think, feel very normal and natural for an assistant, or for interacting with an assistant.
Yeah, I think many of us, think of engineering terms, right? We are building a machine, not a human. But I have to say that the problem of illusion is terrible, and we still have not solved the problem of the machine understanding what it does not understand or doesn't know how to do that. right? So it's a, but.
And then communicate.
And communicate. So sorry, I didn't understand. I know what you want, but I don't know how to do that. Or so, so they're very simple thing, and we don't know how to do that, right? The other thing I wanted to say is that these assistants that we build, they are very limited. So if you think about that, you know, we have been building for at least a decade assistants that do pretty much the same things. They tell you the time, they set a timer, set an alarm, you play media, home automation, and jokes and things. So and the question is, can we go to the next level? And the answer is probably not, because what is the next level? The next level is open conversation towards a goal, like the same way I talk to an insurance agent, or if you want to talk to an insurance agent, but or talk to a travel agent, or talk to someone who knows how to, you know, the restaurants in Doha, and gives me advice on where to go to eat. So and we still can't do that. Right? So my question is, are we moving towards that? Or we always staying here, setting timers and alarms and reminders? Yeah. So.
I think Fadi's question was more related to something like, can we explore language learning type approaches and bring them into more of machine learning, speech recognition type approaches? I believe there was some work when an MIT professor recorded his own child's data over a period of time, and there were a lot of such children-like databases, but I don't think we have enough of them to explore. And every time we've tried to include something related to speech science into building speech recognition systems, we have either hurt performance or not, we don't know how to use them intelligently. So perhaps that's one way to bring it into representation learning going forward, but what do I know? I'm just speculating here like everybody else.
Coming out of the time of where our work was based on pattern recognition, I think you are still there, but the difference is that, first of all, from that time, we moved into approaches which are mathematically founded. I think that's a huge progress, whatever version we apply there. Secondly, why do we feel we are engineering it? We had, over all the time until now, many, many heuristics to patch systems together. We got better on that. And the other thing, which is now with the neural activity, just in general, whatever architecture we take, is across all areas of pattern recognition, say imaging, we saw it today, and many other areas. We talk now in all these areas about same technologies. And image recognition made progress differently than us. We actually can communicate across the areas, and that's important. That will give us more insight. And I do believe also structuring our big models, we need to learn why is that happening. I mean, one way might be that we say in this layer, in this thing, we might patch a little bit, but then we need to understand and formulate it in mathematical terms. And sure enough, that is all driven by data. We need more data, we need more. The way of the representation is a harder one. So can we go directly? But the other part we look also in, when we started out, we had a very simple task, get some digits, get this and that going. The expectation raised a lot. And we got a lot closer to it. And you mentioned a lot of good things saying, can we recover? Not yet. And the question is understanding a bunch of distributions? Thoughts?
So if we were to collect all the responses on what we think we cannot do, perhaps people in academia can go to the government to have a program to address these specific types of tasks, because they...
No, this is one of the things that some of the things we're going to skip in the video, they touch upon this. So talking about the mathematics, so Herman Nye sort of articulated it fairly well for me. He said, look, we have made a lot of progress and these things work amazingly well, but you know, part of the reason we don't really understand them is we don't have a good mathematical formalism. We have models with hundreds of millions of parameters and all sorts of nonlinearities and a hopeless optimization problem if you think about it formally. And yet we go about it, and maybe we get something reasonable. Is that the best? He asked questions like, we have these architectures now that you have pretty much settled on. There's a matrix vector multiplication, followed by some component-wise nonlinearity, followed by another one of those, and then you make a skip connection, and then you repeat, right? He says, why should this be optimal? Like, what class of things does this represent? What else is in that class? And, like, and he almost said it like, our colleagues in mathematics are failing us. They're not rising to the challenge, and so on and so forth. So that was one thing that was articulated. And the other one was going back to your thing about I think maybe it was Fadi, about multimodality, that we are still scratching the surface of multimodality. Like, we really should be going whole hog into it to understand how learning works. And maybe this has given us the tools to sort of, do things together jointly with others and so on and so forth. Yeah.
I don't know. I harbor a certain amount of skepticism towards the mathematicians. Ever since they told us that one hidden layer was definitely enough, and you shouldn't. I mean, in the 80s, you were criticized at conferences if you used 2 hidden layers, because they were all referring to this paper where it was proven that you only needed 1 hidden layer. And it took us 20 years to try it again with more computing, and lo and behold, it worked much better. So I have a certain amount of skepticism, but what I do believe is really lacking is that element of interaction, this question of would a system learn if you just exposed it to a gazillion hours of speech, totally unsupervised? I agree, I don't believe it would, and a human wouldn't. A human would not learn, right? It's critically dependent on parenting, interaction, feedback, weird concepts like love, right? I mean, affection, emotion, these things are crucial, right? And we do this on a daily basis, adapting to new information, right? And there's none of this right now. It's all batch learning, right?
Just want to touch on a few points. One is on multimodality. I can agree with you. My intuition says that the problem is actually going to be easier if we add all the modalities. We're making it very hard if it's audio and text only. And this is why we invent techniques like wave to vec or best RQ. It's a hard problem, and yes, we made progress. If you add the other modalities, there are other clarification signals that tells you what it is, and suddenly, wow, it's actually an easy classification problem. The one other thing just related to the architectures and stuff, I just have personal opinion, we perhaps spend too much time on that, whereas the loss functions perhaps can help us more, like another skip connection, or we have a conformer and transformer. I always make a joke, foobar former. Like, I'm not sure that's, yes, somebody will make it work, but that's not as exciting. I think the loss functions that somehow bring the knowledge to bear perhaps is worth investing in.
Okay, so while I'm going to ask Desh to do something with the video, I want you to think about one topic that we should work on, like let's get back to the engineering, if you will, that we should perhaps focus on in the next few years that might have a big impact. So just give it a thought, and Desh, just skip the second video, go to the third one and cue it up, and we'll just play that after we do this round. So Bhuvana, what should we work on next? Not what we should work on, what's a key problem whose solution would help us a lot?
Like I said earlier, I don't think we've brought any knowledge we had of speech signal processing into our models. Okay. We've repeated this along many times, right? Like we have lots of parameters, we have lots of data, we blindly throw it in, add some targets and say, okay, predict the next token. So I think we should focus a little bit more on speech signal processing and what we know about language modeling and information theory back into the concept of neural networks.
Okay.
Yeah, I think there's a lot of areas to work on, and the one that is coming, one of the top of my mind is the learning itself, the data itself. So we spend a lot of time to say we have a fixed data set with fixed labels, and now we're all about how to do deep learning on top of that. But a big problem, I think, not only in practice, also in theory, is so which, from all the data, what of the data do we pick? What are the labels that we have at our disposal? What are the weak labels, feedback labels that we can collect? It goes back to a bit reward. What is where we need a teacher, need someone telling us what is a correct label, and optimizing that selection. And that selection, I think, is not independent of then finding the right parameters for the model that we build. So to me, it strikes me that we looked only at half of the optimization problem so far. The other half, I think there's a lot to do, and we're living from very heuristics. And it's not even clear, so perhaps that's fine. But I don't think we really understand that yet. And it feels like there's more to optimize.
I just repeat. I think multimodality is where we should invest. And it's beyond speech, image, and audio. Humans have so many modalities. And
yeah, I was going to say multimodality, but Johanna stalled that. But if I have to choose, another thing that I really would like to see solved, that I would like to work on, and I've been thinking about that a lot, is when you build natural language understanding systems for assistants, there is a lot of manual labor involved, a lot of manual labor. So we used to build grammars by hand, but we don't do that. We use neural classifiers, but creating the list of intents, for instance. In an assistant, there are thousands of intents, right? So, and that requires people, requires linguists, requires a lot. So I don't want to fire linguists like our beloved Fred Jelinek wanted to do, but they do a lot of work for that. And so I think talking about illusions, it's an illusion that neural network do everything automatically. No, preparing the data takes a lot of work. Creating an ontology of intents. So can we work towards removing that? Because that's why natural language understanding is behind, for instance, with respect to speech recognition.
Yeah, and I think to add to this, it comes from the fact that we as humans, again, extract the data from interaction. And in the neural networks, we prepare it all nicely so that the algorithm can consume it, right? But to gain data from the wild is an open problem that we don't have solutions for. One thing that hasn't been said, and I would agree with everything my colleagues have said here, but one thing that we're tinkering with is also weight factorization. That's a technique where we have a few papers on, which opens up a automatic learning of creating structure in your representations, which allows you to throw the network into a different mode, right? So you can make it into, because our knee-jerk reaction right now is we train for everything, we create a database, and then we have the linguists and to prepare everything, right? But that means we have for each language, for each emotion, for each speaking style, for each noise conditions, for each one of these things, we have to collect another huge database, right? If we can factorize all these phenomena and treat them separately, such that we can combine them and interchange them, it becomes cheaper. And we're getting some very good results now for multilingual speech and a few other things, because it's applicable to other domains.
So I'm surprised none of you said explainability or, the reason is that when I think about these models, they're not only getting bigger and bigger and more complex, they're just getting impossible to understand. And I don't have the solution on how to do this. Maybe we need to factorize the models in some way like you're suggesting. Or currently there's a lot of work on doing things like saliency maps or something to figure out which part of the input influence the output, or doing some probes. But it's not the same thing as if you got advice from a doctor and he said, oh, I think you need to go in for surgery, look at this x-ray. He's not going to say, I've looked at the X-ray and I have a 95% confidence that you need surgery. He's going to say, look over here, there's this gray, and that basically indicates there's water in there and something, something. You know, so we are used to an expert explaining to us why they reached a conclusion. And that's what I would like these models to do. And so Jim Glass had an interesting idea in our conversation. He said, can we make that also a machine learning problem? So build a classifier and then build a text generator that works with that classifier and explains the answer. So it's a cool idea, but I'm not saying that's the only way. All I'm saying is I feel that maybe this understanding of the models, and it ties in with Herman's thing about if we had better mathematical frameworks, then the framework might say this is the optimal model because this is what it does and so on. So that was one thought. Audience, any other things that we think are very important? Thomas, stand up and...
Okay, yeah, actually I have a couple of things, and they were largely already mentioned. So I think having a model that has a strong bias to need less data, I think everybody agrees on. So having actually more structure in the model, right? So like the human brain. My favorite, of course, is understanding human-human conversations that are long, not 3 seconds long, like a Alexa conversation. And I think one problem that we all probably face is, for speech recognition, we have a fantastic metric, word error rate, which I think most people agree on. You can put some emphasis on low frequency words to make it more, content-driven. However, most people agree what is the right answer. For speech understanding, this is a completely different thing. Like, for example, if you summarize a conversation, what should be really the salient part of the conversation that needs to be summarized, et cetera, et cetera. So I think besides having the models explain things, actually also agreeing on that the explanation is the right answer is a really, really challenging problem. So what are your thoughts on that?
Actually, I just wanted to follow up what Alex said, and maybe just play a little bit devil's advocate on it. It's like, do humans really have structure that we in our models, or we generalize well? Yeah, but is that structure, or we just can explain? So I think perhaps it's semantics. The other feedback on explainability, I think it's important. There's been fairly nice progress on it, especially in the context of these large language models, where the model can tell you why it got to it through a sequence of induction, like multi-step reasoning. So rather than try to analyze the model, you ask the model what were the set of inference steps that got you to that point, which starts, in a sense, the model tells you why.
And we got worse and worse and worse with time. The Markov models were already very hard to explain.
Mike is done.
Okay. Sorry. Do I have to repeat myself? So I say that we gave up in explainability when we moved out of the rule systems in the 1970s towards templates and data-driven systems and so on. So it was harder and harder and harder to explain what system.
But there was a good reason. It works better, right?
Exactly.
It works better.
So that was my point,
train
right?
Globally, right? And the more we go, the more, I mean, from going from hidden Markov models to neural networks to end-to-end, et cetera, we keep giving up more and more of the design that we put into this and give up to this gigantic amorphous learning algorithm that figures it out altogether, right? But I think that's a trend that is bad because it makes the thing less controllable and less explainable. And so,
but they work much better.
And they work much better. So what we need to do is we want to have our cake and eat it too. Create models that still give us this global optimality in the learning, while at the same time enforcing a bit more structure. And that's what I'm saying with factorization and with maybe, you know, the brain too has structure. You've got a visual cortex, an auditory cortex, etc. It's not complete tabula rasa, one big blob, right? And I think that structure is important for us.
We'll take a comment from Fadi and then move to the next topic.
Okay, I hope these two comments are not too long. I think I have two main things. One is dynamicity. We're missing that in our models. Today, we build models, they're static, and that's it. The way we learn as humans, we predict something, and then if it's not consistent with our observations, we change our model. So during prediction, we change our model parameters in our brain. That's how we learn, right? And I feel like we're not targeting this because our models are always static. Second point, if you don't mind, thank you. The second point that I have in mind is following two things here. What Johan said about multimodality and emotions. And I think, I totally agree, I think we need that. My problem with emotion is, it's not about predicting emotion only, it's about the impact of emotion on my correction of my predictions. And that's, basically we need some sort of a reward system to the model to actually help it to change its future projections. Would love to hear your feedback.
All right. So let's move on to another topic because I do want to get to it before we finish. So this was the question, so they stayed up and let's go. So what skills should new researchers to the field acquire? You know, what advice do we have for
when I
incoming
teach,
students?
you know, the speech processing class, I spend some time talking about speech, how it's produced, and the acoustic properties, just because I feel if you're going to be exposed to this area, you should know something about speech. I continually am amazed. You know, there isn't enough of that, unfortunately. We have entered an era where you can just treat speech as a sequence of observations, you know, and then build your model on top of that. So you don't need to know much about speech. I feel there is benefit to that, but I don't know if that's a losing battle or not, actually. So it's kind of sad. I think it's useful to know something about speech properties.
See, it's all very well for them to build technologies which will make sense and so on and so forth. But I think the fact that pedagogy is taking a backseat, it's a very serious problem for the science to progress forward, irrespective of whatever we do. You know, if tomorrow some other technology comes, we will not even be in a position to adapt to the new technology because you don't know the science. If you find that people who went from classical machine learning to deep learning was very easy because they knew the science. Now you create a bunch of engineers who only know deep learning and nothing more than that.
What we do is we teach them about phonetics and phonology. I don't go into, you know, huge amounts of detail. And then they just get to do some exercises with prompts. And they learn a lot about what to do and what not to do. And then they start using that in their homeworks. And they build their models on that. And of course, they want to just build deep learning models if they are computer science. I got some students from linguistics, so it just doesn't, you know. But anyway, I sent you my syllabus and you'll see the kind of things that we are trying to, because to get them onboarded, they really have to know a lot about linguistics, probably more than I can teach them, but also a lot about phonology and phonetics and everything there is to know, hopefully. Well, at least a lot of what there is to know about speech production.
The thing about the student training, I find that's really important and fascinating area.
Yeah, so let's stick with that for a few minutes. Yeah.
Yeah, I mean, you may recall that was it oh golly, I've forgotten which was it Shanghai or anyway, was it the Shanghai Interspeech? So I proposed a tutorial called Speech 101, which was and the subtitle was what everybody working on spoken language processing should know about spoken language.
Okay, I missed the Shanghai Interspeech, but I'll go back.
Yeah, so it was one of the tutorials, and when I submitted it, I thought, well, this is going to be rejected outright because it's, you know, it's not in the normal vein of tutorials, which is usually the very latest thing, and you know, they're very popular. Not only was it accepted, but there were a phenomenal number of people signed up for it, which was incredibly, you know, confirming for me. Nice. People were obviously very, very interested, and also I'm kind of thinking, well, don't you know this already? I mean, you're in the speech field, don't you know all this? And so it was confirming, and I thought, okay, this is needed. By the way, they're now on YouTube. I uploaded them last week. Okay. There's 3 hours.
Yes, by the way, his videos are all on YouTube. It's worth looking at them.
At least good to know the history, where we came from, how did we evolve. I think that's one thing that's missing. I think many people, you know, just know what's there without knowing how we got there. And I think that's dangerous because if things change again, they'll have to, you know, again, redo everything without, but if they had a general background knowledge, the recycling and changing wouldn't be as dramatic because all of these are similar, just to have different hats and different names. But a lot of, like, you know, whether you do call it adaptation, you call it transfer learning, or, you know, it's helpful to know what has happened before and how we got here, and because inevitably we'll go back to some of these techniques. So yes, I would be in support of a broader education. In general, you know, things like statistics and optimization and just the basics. And then, of course, you know, things related to neural networks. But one thing I do find, maybe we'll do a little bit more than before, is the connection with vision. Image processing. And I think, so for a while, you know, speech was really ahead, right? Speech recognition was always ahead, but I think computer vision now is also having some really interesting techniques and algorithms that we can benefit from. Same thing with NLP. So I think, so maybe the biggest change has been more on, you know, exposure to computer vision, exposure to NLP, more formal exposure, because I think those fields, I think they are introducing very nice and interesting techniques, which could be beneficial. So that probably is the biggest change from 10 years ago.
Random processing, you know, statistical signal processing. You definitely want them to know. They definitely you want them to have a really good understanding of digital signal processing. Yeah. Sort of the base, you know, what's now the basics, but before it was kind of advanced. But you know, and so they know it, so they can look at signals. They know how to relate what they see in frequency with what they see in time. And they know why the signal looks the way it looks. I think as much of that as they know is helpful. I won't say they have to have complete knowledge of that, because that's something they can gain, you know, as they are working. Right. But and you want them to know, so all the basics they need to know, you know, and then they don't have to know deep learning coming in, because that's something they can pick up. But I don't want to lose the speech acoustics and the speech science part of it, because I think that that's critical to really understand what's going on physiologically and perception was important. I think speech perception is very important because the signal is so complicated, but knowing what are the things that you really have to pay attention to and the others that you don't. So you need to understand, you know, masking and what the ear is doing and what the brain is doing, and, you know, as much of that as possible too. I think neuroscience is a very important field now. And I think that understanding that, and maybe you're not going to understand it as well as a neuroscientist, but you want to be able to have conversations and be able to learn from them, because I think there's a lot there that you can bring to bear. Oh, definitely. Yeah. Definitely. that's a huge part if you're going to use AI, is that you have to, students need to be informed about how to use AI, how to think about the problem well before they even start collecting trainer data, so that they try to make sure that they remove any bias that they think could be there, that is removed.
I was talking about bias in the data.
I'm just teaching a conversational AI course this term, and I did talk about a little bit about how to read spectrograms. You know, in fact, one thing I want to bring out is the tools change, but speech doesn't. The human speech is human speech, so the tools change, and the tools change quickly. And maybe now, you know, it's all kinds of fancy schmancy deep neural networks. Maybe in about a few years or a decade, then we have some other thing. I don't know. Who would know? But speech is speech. Until we actually solve the problem, we need all kinds of tools. Yeah.
Just maybe because I'm old school, but I really like looking at the signal, listening to the signal. And so when I see things that strike me as weird, you know, how could the system envision that? I go and I look at this signal and I listen to it and I believe my eyes. And you know, I don't know. I guess if you're an engineer and you're a machine learning guy and you're only interested in machine learning, it doesn't really matter what you apply it to. You're not going to look at the signal. But I find it too bad for people who call themselves speech scientists if they don't look at the signal.
Lori advocates listening to your test and training data.
I have something else to say about data sets that I worry about, right? So in the old days, we used to have sort of like DARPA evaluations where you'd have a new unseen data set. And also, we didn't have so much compute, so you probably couldn't really do thousands of experiments. But nowadays, certainly on some data sets, people really have done huge numbers of experiments on the test data, and you're really not quite sure what these numbers mean sometimes. So that's sometimes something I worry about. I guess about people, the way people go about doing experiments and exploring things. And if you're too much focused on getting a slightly better number, you might not be so worried about, well, actually, is this generic? Is this going to apply? Would I really expect if I had some new data of a similar sort it to work? And so the fact that we don't have so much new data of various sorts, you know, I think is a bit of a problem sometimes. What people want from, say, reading a paper, that they want to have a good take-home message. They don't really care what the number is, whether that number is slightly better than that number. They want to learn something which they can apply different contexts and really understand something better, I suppose. And it's very easy to get obsessed by saying, oh, well, this is a table of numbers and I want my number to be slightly better than, you know, the other numbers. Of course, that perhaps helps, but and is a nice thing, but you're really wondering whether it applies to things beyond that data set.
So Phil's basically saying, stop publishing on Libri speech. No, he didn't say it that way, but basically he was hinting that we shouldn't obsess over numbers in these papers. Instead, ask yourself, what I learned from this, will it carry over to something else I'm interested in, and so on and so forth. But anyway, those were my academic colleagues. You're still an academic colleague. So what do you think we should be teaching our students?
Well, of course I agree, you know, but I always catch myself wondering, is it because I'm getting old that I want people to learn about all these old techniques, or is it really a fundamental thing that they should know about? I mean, we don't teach them about vacuum tubes anymore, but I think there is, most of the points I would agree. I mean, you should know something about signal processing, you should know something about acoustic phonetics, etc., if you're getting into this field. On evaluation, I think evaluations have done, so Libri speech and things like that have been very important to drive the field forward. But I think as a field, we also need to remember human beings always train on the test data, and we're telling our students not to do this all the time, right? And so it's dangerous to always go in this batch mode and just to collect a huge amount of data and then train on it and test, because that's not ultimate. I agree with my esteemed colleague here that it's about communication, right? It's about the interaction. and we should make sure that we don't miss the point.
Yeah, of course I agree on everything. What should we teach? Again, probably because I'm becoming old. I think that it's important to know the history. That's why I wrote 2 books on the history of speech recognition and assistance, because I wanted to preserve that, and for the future generations. On the other hand, I think I went to University of Pisa, which is a very old university in Italy. They didn't know engineering very well because the towers were always leaning. But there is an inscription from the 17th century that in ancient Italian Tuscan, I am from Tuscany, so I love the Tuscan dialect. It says, "Chissà sa che un sa sudanno." That it's hard to translate in English. It means those who know, those who don't is their problem. Right? So I mean that maybe students they can learn how to use neural networks and deep learning to solve problems. Maybe they can do, one of the questions we ask the undergrads student, or they ask, the professors ask, is how do you reverse a string? And maybe the new students would say, I take a lot of examples of strings and they reverse, and they train a neural network to reverse a string, right? So they could do that, but I believe that the stars, the geniuses, the people will come from those that know a lot, not just what they have learned, but also about the other fields and about the in our case, speech and natural languages, these things. So if they don't, it's probably their problem, but there would be people who are curious enough to know about this and learn about this, and then I think the next great things will come from those people. Yeah.
And perhaps one person which will not say let's teach speech signal processing, but teach our students how to be good scientists, how to do good experiments, look at the data, which doesn't require understanding speech per se, but being a good experimental scientist, make conclusions. If you're too specific on this field, I mean, a lot of advances in speech came outside the field. And so I just, it says, be more generalist and be a good scientist, rather.
Yeah, I think what I like to see from scientists working in industry is we have large systems. So I think we need scientists who understand the whole system end to end. Then we need scientists who understand the data, to understand what is going wrong where. So yes, looking into the data, I think it's crucial, and learning that is crucial. And then from there, make the conclusions, where's the right point to go after improving it, build up your hypothesis, what needs to change. And then being able to dive deep there and come up with something. I think that requires often at least some good foundation of math, of signal processing, so on. And then once you have that, I think nowadays you also need to know how to translate that into better models. So you also need to have some basic understanding how deep learning works, and when your system is not converging or you don't see the results that you expect, that you can then go after it and then make it work. As well, actually, perhaps as opposed to just copying a recipe from the internet, how to build a model, which, fair enough, for many problems, it's good enough. But I think we would want our scientists to go deeper.
I think we said a lot about signal processing, but I think statistics is important. We need to teach people to measure the significance of their results. 0.1 at 30% error rate isn't exactly progress. So a lot of the stuff people do, we like to write papers, I'm guilty of that, and we report such tiny differences, but I think when people get to learn more about statistics and information theory, they realize what's more important. A lot of the approaches in speech are interdisciplinary. So we've borrowed a lot from NLP and mostly from vision, image processing, but many people don't quite understand the difference in the nature of the speech signal compared to what an image looks like. And perhaps if they went deeper into that, they would morph the techniques that are working well in image processing to speech recognition or any other form of speech signal processing. So if academia actually taught them the differences, that would make a world of a difference, I think.
So I agree, we should basically be teaching them how to do good science and learn what it takes to do good science, including things like speech production, perception, cognition, and other things like optimization. Audience comments. Anyone has any feelings on this subject? Advice for young researchers. Jimmy, please. Dong, you haven't said anything. Maybe you have some ideas. Think about it. No, but Jimmy first.
So, Bhuvena, you summarized a lot of the things what I wanted to say. Essentially, have solid basics. Johan, Björn said, be sure to do proper experiments. That's important. Now, what should academics teach the people is machine learning, because that's the common language. And being built up recently, a large team of scientists, they came from a lot of different areas. You mentioned also some of them. Imaging, fraud detection, think about that, robotics. If you put them all into a team and build a science team out of that, they need to know teamwork. I think that's important. And they need a common language. And our machine learning area allows now to communicate amongst people. And then actually people can come up with complete new ideas and new ideas to solve problems. And then old topics are coming back, like moving Alexa on device, doing compression techniques into machine learning, then having different models, like switching automatically between using one model or the other, using some status, enables new things to do and advance the area. And it's then, along us seniors then, to explain them the details of our area, spoken language understanding. It's more like from a signal level or up to the dialogue level. And then we get complete new things. And that's what students should know. They should be confident on what they know and not afraid anymore to switch areas, if you phrase it that way. And hopefully they come to us. In terms of, the area of spoken language understanding, to drive all the topics what we raised and say where we need to make progress.
Right. Thanks. One last audience comment before we wrap up. Okay, go ahead, Thomas, make it quick.
I think I just want to re-emphasize the importance of being a good experimenter, and if things go wrong and you get bad results, how to fix it is important. But if things look they are going right, be critical, because it might not be right. So be wary of too good results. I think it's something that people will learn usually the hard way.
All right. Okay, so this debate, by the way, is going to go on for a while because I think we are at an inflection point in our field where we have overcome some long-standing problems. And so now we're getting ready to face the next round. And we're in this phase where we're very happy about our success, haven't quite charted out where we're going next. We do know that there's a long way to go. So I have a feeling this debate will continue, maybe in a similar discussion at the next meeting somewhere or through some other forum. So please engage with this, especially the senior people, because we do have to figure out a path. And there are a lot of very talented young people coming up, and we need to give them the right pointers to go and do the next big things. So with that, let me thank all the panelists here again. Thank you very much, and all the remote people with whom I had interviews, thanks to them in absentia. And thank you all for listening and joining the discussion. So the next phase, we did add one item to today's agenda. The technical program chairs are going to give out the best paper award. So Mark, come on up. And I have the honor of actually handing off the certificates to the winners. What we'll do is, let's see, we should improvise with the current setup. Desh, do you have the slides up here as well? Yep. Oh, they're all up here. Okay, perfect. All right, so let's give Alex a minute. Yeah. No, it's okay, it's okay. Don't rush. Thanks. So we will modify this just a little bit. So as you know, we were looking to give out a Best Paper Award as well as a Best Student Paper Award. And there was a committee, and I think Julia sort of coordinated some of it, right, Mark? Or yeah. And there was a group of steering committee people that took in feedback from the various area chairs and so on and so forth. And in particular, we had to make some special arrangement to manage conflicts of interest, because some of the area chairs also had papers which ended up being in the list of finalists. And so it was done very carefully so that they had no insight or input into any of those papers, didn't know who reviewed them, and so on and so forth. And at the end of the day, we have some, actually, there are some very nice papers. So when I think about it, there were 9 finalists, right? So the 9 finalists need to be very proud just for being in the finalists anyway, because think about it, there are so many papers in this conference, so many were submitted before that, right? And among those are the 9 best. So first, let's just give a hand to all the 9 finalists. And the committee had a hard time because there were a lot of good papers. And so the first 2 I'm going to announce are honorable mentions. So they were in the running. They didn't win the best paper, but they were close enough. So the first one is titled PEPANET, Effective Mispronunciation Detection and Diagnosis Leveraging Phonetic, Phonological, and Acoustic Cues by Bichen Yan, Xinwei Wang, and Berlin Chen. So are any of the authors here? No? Okay. So let's congratulate them. And the other honorable mention, again, this is in no particular order, these 2 were both very close in the running, is the paper titled Style TTS VC, One-Shot Voice Conversion by Knowledge Transfer from Style-Based TTS Models by Yinghao Li, Kong Han, and Nima Mesgarani. So Nima, are you still here? No? Okay, all right, so let's again congratulate the authors. So these are the honorable mentions. Next up is the Best Student Paper Award. So it goes to the paper titled End-to-End Integration of Speech Recognition, De-reverberation, Beamforming, and Self-Supervised Learning Representations by Yoshiki Masuyama, Xuan-Kai Chang, Samuel Cornell, Shinji Watanabe, and Nobutaka Ono. Congratulations. I believe Yoshiki is here. Yoshiki, are you in the room? Yes, please come up. And then comes the Best Paper Award. And I have to say Best Papers Award because there's a tie for this one as well. The first one is the paper titled FLIRS, Few-Shot Learning Evaluation of Universal Representations of Speech by Alexis Kono, Min Ma, Simran Kanuja, Yu Zhang, Vera Axelrod, Siddharth Dalmia, Jason Reza, Carla Rivera, and Ankur Bapna. Are any of the authors here? I think Min is here. No? Okay, all right. Let's congratulate the authors again. And the other winner of the best paper jointly is on the utility of self-supervised models for prosody-related tasks by Guanting Lin, Qilin Feng, Weiping Huang, Yuan Zheng, Chen Li, Suhan Lin, Hangi Lee, and Nigel Ward. Congratulations. Any of the, Hangi is here, right? Hangi, please come up. Yeah, no, come on, yeah. And the winners of the best paper and the best student paper should go to Shamur over there, because they do involve a cash prize, and she will give it to them. Mark, do you want to say anything more? Okay, so this concludes the day's session. I do have logistics instructions, and Ahmed or Shamur will tell me if I'm wrong. The logistics instructions are that the buses are going to leave from the door which is just outside to the left in about 10 to 15 minutes. I think 10 minutes. The departure time is 4 o'clock. My clock watch says 3:50 now. So you have 10 minutes to wrap up, grab a coat, and head out for the gala dinner. All good? All right, see you in 10 minutes in the bus.
Thank you. That was efficient. Yes.